Hey, I'm Max Ron and welcome to Making Metal with Max. On today's episode, we're going to be finishing off metallurgy and talking about classifications and why that's important. So check it out. Hey guys, I'm Max Ron. I'm an instructor at Polytechnic, and I'm also a member of the Canadian Welding Bureau Association Regina chapter, and I hope you guys check it out. On today's episode, we're going to be talking about classifications and why that's important and why you need to know that, all right? So, like every episode, what are we going to start with? We're going to start with why, all right? So the big why. Well, everything that we've learned in metallurgy up to this point, the carbon content, the durability, the hardnesses, the ductilities, the malleabilities, and mixing them together and taking them apart, the tempering, all that stuff that we've learned has led to this point. Now, I say that because that's a huge language that we need to discuss in terms of terms and conditions to talk about steel. But how do I talk about it on an everyday conversation, right? So the very first aspect that's important to understand about classifications is for purchasing, okay? If you want to walk into a business and order some steel, or if you want to buy something, you need to know how to buy it, all right? And you can't just say, I want something that's hard but not too soft, that's kind of bendy but not too bendy, that's good with heat but not too expensive, and then I can get readily available in my hometown, wherever that is, by tomorrow. That's not a conversation the sales guy at the steel store is going to enjoy. What they would like is for you to know what you want. Okay, now the first part about purchasing steel that I want to tell you, and it's going to be a theme with every aspect of classifications now, is that find the chart. Okay, there is so much information out there, and it's constantly evolving. Like they say, those living documents. It's always something new getting developed every day, and tweaks are being made to the designing and also the requirements of steels in the world. So if you want to order something, one of the first things you're going to have to do is find a chart in regards to what you're trying to do. I mean, there's probably people out there that are really, really smart and can remember everything, and kudos to them, but I'm not one of them. And I have some general numbers that I've remembered over years of experience working that I've come to my memory if I have to talk about something. And I kind of know what I like to buy because I've bought it before. But with that knowledge, that knowledge comes with experience. I still have to go to charts to figure things out sometimes. The second part about it, I would say, is design. Okay, so we got purchasing, we got design. So that's on the engineering building side. I need to know what I'm building with and what it can withstand and what it can do. I'm going to use different steel for tanks that I would use for bridges, that I would use for rocket ships, that I would use for wear plates in a potash mine. I will need different things for different jobs. So as an engineer, before I can even really start working on a design, I need to understand what it needs to require, and then if I can get that and how easy I can get that. It's like aluminum. Aluminum is what? 1/3 the weight, 1/5 the strength. Well, those aren't even numbers. So if I just go to aluminum, okay, I lost 1/3 the weight, but I'm going to have to make it 5 times stronger in design. So when you make different changes in steels, you also have to have those thoughts in your head. If I make this lighter, I'm going to have to design more. If I make it heavier, well, maybe I'm going to have to worry about where it's going and what's happening, right? So that's design. The next thing you're going to have to remember, and I already said about this, and I brought it up right off the top, is charts. So this is the metallurgy part. There's a lot of information, right? So find the chart, go through it, familiarize them. I want to put some up throughout this presentation. The generic charts, if you guys have gone to school, you're going to have seen them before. Sometimes people will even talk about numbers and letters that they've seen in charts or in shops or in their lives without really understanding what it means. Common ones are like AR plate or QT 100 or numbers like that. What does it mean? What do I want? Or how do I order that? Or what does it mean? Find the charts. And the last thing that's really important that has to do with classification is testing. Okay? Now, I need to be able to test my materials. I need to be able to test the product. And I need to be able to test the welder. All right? So all of these are important. So you got welding in here. You got building. and then you got design. And all of these are testable components of any type of weldment, right? So if I want to get a ticket, I need to know what kind of ticket I need to get for the job that I'm going to do. And I bet I'm going to find that in terms of classifications, whether if I'm in the US or ASME coding, I need to worry about F3, F4s or F5, F6 or whatever. Or if I'm here in Canada and I need to worry about, my CWB tickets that are registered under CSA. All right. So why? Purchasing, design, metallurgy, and testing. All right. So let's get into this a little bit as best we can. So when we start talking about the classifications, right off the top, I talked about how you need to have everything accounted for. So the furnaces, like in episode 1, the hardnesses and ductilities, like episode 2. We need to have all the information that's led us to buying this product in front of us, right? And the easiest way to do that is to have things put into groups. Now, every area kind of has their game, and it's for certain reasons. So I'm going to put Canada here. I'm going to put international here. And I'm going to good old USA over there. All right. So everywhere needs to have kind of a language to discuss how a job's going to work. And just like mathematics is a universal language that we use, classifications are our language in the steel industry. Okay. And it enables us to have communications between areas that would otherwise be very hard to do. All right. I don't speak Portuguese. I don't speak Mandarin, but I should be able to go as a steel worker to China or Portugal and figure out what kind of steels I need for a job based off of a classification system. Right. And I can at least figure out numbers and letters and show it to somebody and say, I need this, and they can get it for me. Okay. And they'll understand it and even maybe give me recommendations based on their geography and what's available to them. Right. So Canada's an easy one. We have the CSA, the Canadian Standards Association, okay? And underneath this, because this is a wide umbrella, all right? In Canada, the CSA governs almost everything. And because our systems in Canada are regulated and certified, it's a huge thing in the world. Canadian employees' standards, codes, and certifications are wanted around the world. I've had many international jobs because of my CSA qualifications or education. All right. Now, this wide umbrella of classification systems has a little offshoot here, which is the CWB, which has to do with steel and welding. Okay. Now, that's steel education, steel certification, steel testing, steel welding, tickets, all this sort of stuff. Now, steel falls into here. And like bar, stock, and steel products, okay? So we're going to come back to this and talk about it a little bit more because it's not overly complicated. So this is in Canada. In international, it's very similar to the Canadian style. It's the International Standards Organization. This is a group of countries that have gotten together. It's developed out of Europe because Europe has a very tough geographical situation where you have various different languages, different areas, different methods of production and design, but they all have very close proximity. So like we talked about earlier, language is an issue when it comes to communication. So an area with so many diverse ways of communicating needs to have a standard between them. So having the French standard is not the same as the German standard, is not the same as the English standard. So why don't we create international standards that we can all communicate each other's for projects? Okay. Now they are like us here. They have an umbrella, and then they'll have an offshoot for welding and consumables, electrodes, wires, and all that stuff. Okay. Now the USA is different. Okay. Here we have standards and codes. Here we have standards and codes, and they're all run by governing bodies. In the United States, we have privatized systems, which means we have a lot of different guys getting their hands in the pot when it comes to steel production, steel classification, steel testing, steel management, deliveries, constructions, and every state in the U.S. can have also their own legislations for that area. It can get very tricky. So we have the SAE, we have ASTM, we have the AISI. Let's see what else is there. We got ASME, ASME. And inside of all of these, you'll have, the AWS, which is the American Welding Society. So the standards or the Society of Automotive Engineers, the American Society of Tested Materials, the American Institute or Iron and Steel Institute, and the American Society of Mechanical Engineers. Okay. So what does this all mean, and how do I differentiate between all of these? Because being in Canada, we still have to deal with a lot of this. We use a lot of this. Some of our systems here have chosen to use American systems because they're in some levels better established or easier access. Okay, so let's start with the SAE, Society of Automotive Engineers. Now we're talking about sheets and bars. We're talking about materials of steel. Okay. We're talking the AISI, the SAE and American Iron and Steel. These guys are very similar systems. They're basically piggyback on each other, and they're for purchasing and selling of materials. ASTM, Tested Materials here, this one is more about creating a system of classification for dynamic loads. So that's something that's going to be moving. Okay, so things like bridges or piping and stuff like that, ASTM will have a type of regulation for that. Much like in CSA, our system here concentrates more on dynamic loads. We use a lot of the SAE and AISI for our bar and stock because it's already established and well done. But when it comes to dynamic loads or things that are going to be tested, I'd say in welding purposes, pressure piping, boilers and stuff like that, we want to have more control of it, so we have our own testing and classifications for it. In the United States, lots of that stuff falls under ASME or ASTM. So there's a bit of a split there. ASME has a lot to do with procedural writing. So it's codes and standards laid out for pressure, piping, design, boilers, consumables, all that sort of stuff. Okay? Now, when we're looking at this, you can see that sometimes it's a little bit difficult, even with some generics, to have some standards be universal. Okay? There's going to be a little bit of back and forth. So let's start looking at these a little bit individually and try to remember some key points. Okay? So we said SAE. Oh, I did that wrong. SAE and the AISI. There we go. And see, I got to remind myself because this is a lot of information. Now, these guys are both involved in the production of steel. Okay? Now, very often, the production of steel is going to be bar, stock, sheet, plate, stuff like that. So I'm going to go to a store and I want to buy it. It's a 4-digit system. Now, if I look at a chart is a mini chart because they have like the easy way to remember, and then they have the super duper chart, which is the lots of stuff to remember. And then they have the, you need to call somebody and get the crazy chart if you want to get into really, really specifics. But there are some simple things to remember. First of all, each number here has a reason to exist. First of all, the first number is called the major class. Which just means, like, what is this mainly made out of? You know, like, what's the main thing here? Am I buying iron, or am I buying nickel, or am I buying chrome? I don't know. But it's going to be a major class, and it's going to be the majority of what's in there. Okay? The second one is called minor. Well, that doesn't mean it's under 18. That means that it's less. So if I have a pure something and no other mix, this will be a 0. But if I have something in the mix, it'll be a number. And that number is on a chart. Okay? And if I want to figure out what the majority of the steel is, if it's a 1, it's going to be a carbon-based steel, so just your normal iron. If it's a different number, it's going to be a different metal. Now, these two are a percentile of carbon. Because we're still in the steel world, right? So the Iron and Steel Institute. So in the steel world, we're working with mainly ferrous-based items, right? Because that's what most steel is. So if we're looking at steel, you need to know the alloys in it. And of course, like we learned in the previous episodes, we need to know how much carbon is in it. So if I have, for example, 1040, I will have, like I told you, a mainly carbon-based, so mild steel, no minor, 0.4% carbon. Okay? And that's, that could be 0.43, point whatever. Now, so major, minor, carbon. That's it. Okay? You don't need to get too much crazier than that, aside from just trying to remember the first, I'd say 4 or 5 digits on the list on the chart. Okay, so like 1 to 6. It's like we got this is our standard iron. So let's say Fe. Then I think we got chromium, right? No, it's nickel. So we got nickel, and then molybdenum, and then chromium, and it scales up. So I think 2's nickel, 3's molybdenum, 4's chrome, 4 to 6 are variations of chrome. As these numbers go up, if we think back to lattices and structures and stuff like that, the complexity of the steel tends to go up. And that's not an accident. As the chart escalates, complexity escalates. And also the amount of things you need to know about the materials and what's going to happen to them when they weld escalates. If I buy a 1000, I'm going to be able to weld that much easier than a 4000 because I have a more complex material. Okay, here we're talking about BCC products. Here we're talking about FCP or FCC and HCP products getting mixed in. Again, lattices get more complicated. Everything ties in. Now, everything what we've learned ties into this. Okay, so 1, 2, 3, 4, 5, 6. Let's see. We got carbon, like your normal iron. We got nickel. Then we got molybdenum. Then we got chromium, and they're all like scaling up that level. And after that, there's like tungsten. I think is 8, and vanadium is like 9 or 10. It gets crazy, but you know what? It's really just about how complex and percentage of carbon. So if I'm gonna go buy something and I just want iron, I want to have a 1. Look at the ones. You want iron. How hard do I want it? Well, I want it to be medium carbon steel. Well, then pick a 4 or 5, right? And see what's available at the seller, right? Don't start trying to order something that's magical on your list that you designed that doesn't exist, because then you're going to have to get made and costs go way up. Okay? So that's SAE and AISI. Now, if we go to ASME, okay, if we go to ASME, we're going to be starting to look at generic groupings. So these do speak back and forth. Charts do share information. Agencies do have similar styles, okay? But what ASME has done is that it started to do things into general groups, which are called the P groups, all right? Now, the P groups have an area where it'll be like from this level of ductility, malleability, hardness, temperature, control, iron, carbon, anything in this group is going to be a PX, and then a PY, and then a PZ. There's a variety of numbers that go from up top. The only ones I remember are P6 to P8. I remember that those are stainless steels. That's like all I've ever really remembered. I worked in a hydraulic shop for years building cylinders and high pressure cylinders and high pressure tanks, and we used a lot of chrome and a lot of nickel and a lot of stainless steel, right? And so over those years of working in those shops, I learned the stainless steel classes. For a while I had tons of stainless tickets, and that's what was my game. Just stainless all day, all night, right? And so you start picking up some of those things. Now, do you remember the other ones? I don't really remember, but again, what's the key? Go to a chart. Find the chart, look it up, and figure it out, okay? Don't be ignorant to it. We're in Canada. We don't have to use ASME too much unless you're going out to get tested and work on materials. But if you're a professional welder and you are getting tested, it's good to know what your tests mean, what the tickets are, and how they'll be transferable. Sometimes you don't need too many tickets, and if you get the right combination of tickets and certifications, it makes you very travel-worthy and durable as a welder, right? So we got the SAE, and we got ASME. Then what do we got left? Let's see. We got CSA. We got to figure out CSA. So CSA will have a variety of different testing and coding methods that are in a similar style to all the standards across Canada for all sorts of products. Okay? But there is an interesting thing, and I'm not going to, it's charts, again, charts. But there's going to be some simple things that you can remember. So we got W, we got A, we got R, we got Q, we got T. You're going to see letters when it comes to ordering steel in Canada that are usually at the front. Now there's going to be a whole bunch of numbers. Those numbers are again going to be based off of carbon, major alloys, minor alloys, all the things that every area has developed. It's the same here. We just have a different chart, right? But we use a letter system to kind of put things into group. So very much like ASME and AISI have their own things, but they can work together. In Canada, we have it all kind of in one area, split into sections. Now, this is a welded easy, weldable steel. So this is good for welding, which means it's good for getting heated and cooling. So if I say something is weldable or easily weldable, and it has a W, so a W44 for example, that means that that material is good for welding because it has a great ductility to malleability ratio, and it is good with absorbing and releasing heat without having its grain structure be modified too drastically, and it will maintain its strength prior and post welding. Right? It's a lot of information out of one letter, but that means that a lot of testing went into this group to say that, you know what, without any major issues and without any major pre-set up or interesting ovens or heating and stuff like that, I can pretty much grab a certified electrode and a certified W plate and weld it, and it's going to be good. That's the guarantee. That's the certifiability that I'm getting from a W. As we go up the list, again, like all the other lists, you tend to go up, you tend to get more complicated. So A is for atmosphere. So that means that it's good for oxides. We talked about oxides, stainless steel, all metals oxidize, right? But it's how you react to oxidization. Iron-based metals react to oxidization by turning into rust, which is basically garbage. It's not steel anymore, right? Stainless steel its oxidization creates a little bit of migration, which forces a harder coating on the oxide, which actually makes stainless more durable, but makes it more susceptible to grain migration or sugaring. Okay? And then aluminum, its oxides are like lead to it. Well, I shouldn't say lead, but it's like a very high temperature coating that does not conduct electricity worth of crap, and it gets in the way of welding, which it causes lots of issues, but also makes aluminum wear resistant and not rust and not oxidize visibly to us, right? So if something has an A rating, it means it's been treated somehow to be better with the atmosphere or oxidization. Now, it could also be corrosion from nitrogen or hydrogen, which are also in our environment. So there's a lot of things in our environmental area that can have an effect on steel. If it's got an A, that means that it's been designed to be better for that. Now, if it's an R, that means that it's atmospheric, and this is like doubling up. So we're kind of doubling up on the atmospheric resistance or resistance. Now, why would they do that? A and AR. Why not just have like A and then something else? Well, that's because if I buy an A plate, it's got a certain level of guarantee. If I get AR, that level is now higher. And it's going to introduce a whole new level of alloys, carbon levels, post and preheat stress relieving requirements that have to do with testing and welding. If I get an A plate, I have X amount of stuff I have to do to make it stay an A, because I don't want to screw it up and make it not an A when it's done being welded and it's not good against the environment anymore. If I buy A, it's because I want it to stay good against the environment. So I got to make sure it stays A. Now, if I go to AR, well, now I'm making that harder. I have now more rules and regulations I got to follow to make sure I keep my AR. Okay? Now, when it comes to Q and T, same thing. Q means quenched. And as we've learned, quenched changes the grain structure of the material. It tightens it up and makes it harder. And if you have lots of carbon, say high carbon steel, and you quench it, then you have possibly some issues with carbon or graphite. But if you buy quenched material, that means that it's generally a low carbon steel that's been hardened. So if I weld on it, I can run a high risk of losing that hardenability. Okay? So I may unquench it by normalizing it through the welding process. So if I'm buying Q, I really got to watch temperatures, right? Because I know from my metallurgical background that if something's quenched, I've shrank the neighborhoods of the grain structure on purpose. And I want to keep them there, right? So I got to figure that out. There's going to be a procedure, follow it. Now, tempered is doubling down on that. QT, quenched and tempered, or what they say is temperature control. So QT means that it's quenched, and it's going to have even tighter temperature controls. So you really better be on the ball about how you're doing this, or else you're going to ruin the steel. All right? And ruining the steel can be a big deal. I have been on jobs where things were welded incorrectly and they failed. Some, I would say, failed on site, which is the worst thing that can happen to you as a welder. And it sucks when something goes out on site and fails and you don't know why. And then you go back and you start assessing everything, and it's generally either welding problems or engineering problems. It's going to be one of the two. Okay, if I screw up something here, obviously I'm going to have an issue possibly quickly or down the road. Hopefully, if you screw it up, it happens in your shop or in your garage, and you can fix it or throw it away and start over, which sometimes happens in steel world. I have been a part of some big throwaways, $1 million throwaways, where something is wrong or a material was perhaps ordered or labeled wrong. So that was my last point here to finish off this quick smashing your face classifications conversation is labeling. Okay? If you order steel and it's a certain type of steel, make sure you write down what it is on the steel. Do not mix different kinds together or have some type of system. If you're in a shop, please be careful with that. Like I said, I've been a part of big projects that went sideways because of bad labeling, either coming off the truck, coming from the supplier, or in-house. So be careful with that. Don't waste your money on steels that you don't need. Design versus product. A lesser product but with more design, or less design with a better product, or a combination of the two. There's a lot you can do playing with the knowledge that you have. All right? So I'm wrapping up my quick classification smash. I hope it was good for you guys. We're going to get into classification more in other episodes pertaining to specific processes as we go. But in the next episode, what I'm going to be talking about is I'm going to lead into modified waveform. Now, that is something that I love to talk about. I've been on lots of conferences about it, and I find that it's a machine that you probably have or have seen and have no idea how it works or why. All right, so modified waveform, that is like the Lincoln STT, the Miller RMD, ESAB's got one, Hobart. Every company now has come out with their own version of modified waveform. We had Fronius come down and do a show for us. It was amazing, right? All these cool waveforms that are happening. How does it happen? Why does it happen? Why do we need it? Why do I care? All right, so that'll be the next episode. Probably be a couple episodes to get through that. I want to thank CWBi Acorn. I want to thank my team. I want to thank Matt. Shout out to that guy. He works hard making this cool. I want to thank my sponsors. I want to thank the local companies that are supporting me. If you guys got anything you want to talk about or ask any questions, askmax at CWBgroup.org. Thanks to my Instagram followers. You guys are lots of fun. And, any local company, I got Tentry on, you guys want to help me out, help us out. So I hope you guys stay in for the next episode, and I'll see you soon. Thanks.